Hello, my name is ANSHUMAN Saboo. My register number is 17BCE0141, and this is my image processing review 2. My image processing review project name is Fruit Recognition using Dominant Color Recognition and Feature Extraction. So let's get into the PPT. I will share my screen now. Yeah, so this is my image. So now, as we know the topic, now let's go ahead and see the topic. Yeah, so what is the problem addressed? So the problem we're addressing in this project is obviously because with the age of technology and all the number of great cameras and everything, the images are in huge excess, and with the age of internet and everything, we obviously image has become a part of our lives. And so the problem we're addressing here is many of the times when we use data science models or many machine learning algorithms, we really need good images to process the data. So for a plot or for diagrams, when we extract the data or something, it's not very clear. Sometimes there's noise problem, or sometimes there's a lighting problem. So we're addressing the fact that we want images to be perfect. And here we have taken two images, and we've made, based on some test images which we've taken, we've made it into, for here we've addressed for the farmers for fruits. So basically we take the fruits and we take the fruit and we make it into a cartoon or maybe a animated image which gets processed more into a better machine learning algorithm. So yeah, what is the limiting? So as you can see in the picture, this picture here, right? Oh, sorry, this picture. I'll just take the screen out. The picture here, you can see the problem is that that the picture is very foggy. Now it can be because of humidity or fog, many feature and many problems. And now what they've done is they've used an image processing technique where they've brightened the image, but they've colored image. Basically, they've enhanced the color more, and they've made the color more bright and more colorful, which is not. So as you can see the shoulder, you can see it's too wide. You can't differentiate it more. So it's not perfect, but we really want it to be better. So k-means and more functions which we'll talk about later are better in terms of already what existing. So there's also one movie called In the Heart of the Sea. Now most movies can be, there can be an issue because of the coloring or everything, because of the coloring or anything. Like Batman versus Superman, it's a very dark tone. Now it can be depending on the director how he wants the image to be. But a lot of children or a lot of teenagers prefer images which are very colorful and the movies are very bright. So we can use a lot of these techniques there. Let's go for the. So what do we propose? So k-means, I'll talk about k-means in a better way. Uh, I'll show through a whiteboard where you will understand it better. So let's take a graph. Here we have a graph. Let's take some data points. Normal data on a graph like this, where we've plotted it. Let's take them in different colors so it'll be easy to understand. Mind you, this is data we've got it through some project or we've got it through some place where they've noted down or it's processed somewhere. So now when we have data like this, now what does k-mean do? K-mean, first, what it does is, first it takes out, as these are random points or something, we take out the centroid of it, the main point. So let's draw the centroid. Oh, sorry, I'll undo that. Color, just make it black for now. So let star 2 be the centroid of these data points and star 1 be the centroid of these points. So now we've got the centroid. Centroid is basically the distance of Euclidean distance between these. So now we've got them. As we go ahead and we keep on making more data and iterating it, what happens is the centroid then comes here. Star 1, star 2. Not in the middle, not overlapping. So this becomes one cluster, this becomes one cluster. So your k equals to 2 because we put it as 2. So now we've got two clusters where all these similar points. Now if you have more points, let's take another point and I'll give this another color, green. Now this, because this centroid is near this will then join this cluster and we'll get more properties that. So how we cluster it, or sometimes because if it's equal distance, it can make another own cluster. So that's how it works. So yeah, so we understood that. Now let's go back to the PPT. Let's go back to the PPT. Yeah, so canny edge detection is the same. It's just how we again find the edges. So we've made two methods: most dominant color finder and enclosed area finder. Most dominant color is we will take the image, we will carve out the image for fruits. So we take out the image, we'll take the background out and everything out. We get the image and then we type and we find all the colors. So or we extract all the colors from it, and which is the most dominant, we fill that image and make our animated image a new processed image. Area finder is obviously taking out the edges. So these are two main functions. I've used Jupyter notebooks. Now, why have I used Jupyter notebooks? Because it's the best tool according to me for image processing. A lot of people say MATLAB too. MATLAB is a very strong tool itself, but Jupyter uses Python, and Python is really, really good. And it's the most advanced language according to me, and will help a lot in the image processing later. It's very easy to manipulate and use our data and properly in this. So let's go to the implementation. So let's in our review 2, I have to find the terminal. In our review 2, I've made out the edges. Let's go ahead. So you open the Jupyter notebook. You open the Jupyter notebook through the terminal. So we open the terminal. So I made the file called fruit detection. As you can see, model of creation. So this is our model. The best part is it already gets run and everything. So you can see everything is run. So let's start from the beginning. Skylearn is obviously here. If you can see Skylearn. Skylearn is everything about image techniques and everything. Collection is for dictionary and everything. All our libraries, we basically run. We'll come back to the functions later. Here we have loaded the images where we have the image data. Let's go back and I'll show you. So we have the images here. So you can see one apple. You can see the third image, again an apple. I've given more data and seen how it works here. Now we get the color. This is the minimum color. The minimum color which we get is 66 here. We convert and change it. So basically, if you can see the functions convert and change, we convert it into grayscale. Feature can is obviously take out in the ejections edges. And here we've put in the poly. Here you got to put trial mode because sometimes the images go too high. That's why we put low values for the column headings, everything. We change it and we make it into 255. Either it's black or white. So if it's 000, it's either that or it's 255, black or white. Let's do that. So we see if all are present or not. If everything is present, it's true, it's good. We load our data, then we use. Now we've used. I'm showing here by convert and change. Now convert and change, we get it proper. We use the function, we get a good one. But but the issue, what happens is when we want images like this, we need more data and we need more function. So we'll get back to that. Now here for color function. So as I've taken the color, you've seen I put 7. I can even put 10. That's the beauty of this. And okay, we have to load everything first. Sorry. We load everything. And let's find it now. As you can see, we're getting it. So yeah, so we've got 10 images. I can even give 20 and it'll work. So we get a lot of colors we get. So now again, pre-pro is the function I've used here where they're trying to find all the edges with along. So if the edges is white, the ahead and the back images also become whiter. So as you can see here, the image is becoming more and more broad and broad. So we're giving more values and getting it. They put in false because we don't want it to become too black and like this. So we extract till X4 and we take out. So I've got this image. In the end, I've got this image. Now this is our Apple image. Now what I will do in my next thing is the most dominant color I think here is let's give, because it's a very, very, not so many colors, let's give 7. So as you can see, the most dominant color is slash B B2755. Now we will put B2755 in this image of this, so that we get an image, and that's how we proceed. Then ahead we will put it in an image processing. Let's get back to our PPT. So yeah, conclusion. As we saw, import the image, find the CAN image, convert the image. These are the references, future. So now we will implement the function, generate the most dominant color, and so basically we want our apple to look like this. Not obviously similar. This is a cartoon image which I've given an example for. And in the later we will get an image where we will put this in a machine learning, and we'll show how much exactly percentage same it is, and how we can use this ahead for a project. So thank you for watching it. Thank you.